Please welcome Lars Bernisch, Evonik Venture Capital.
Hello, I'm Lars Bernisch, an investment manager at Evonik Venture Capital, and it's my pleasure to introduce CASTOR Technologies. CASTOR is a software company that assists manufacturers to easily identify how and where to implement additive manufacturing technology, even for companies with limited experience knowledge of its benefits. We believe CASTOR's intelligent automated decision support platform can drive a broader adoption of 3D printing at a commercial scale and contribute to growing the additive manufacturing market. I highly recommend CASTOR as a Falling Walls venture science startup of the year 2021. Thank you.
Breaking the wall of costly additive manufacturing, Omer Blyer, CASTOR.
Hi everyone, I'm Omer. Thanks again for the time and the opportunity. We're called CASTOR and we're the manufacturer's gateway for industrial 3D printing. A bit about myself before we dive in. My background is mechanical engineering, but I also hold an MBA in entrepreneurship and innovations, both from Tel Aviv University. This is where we sit. I used to work for a company called Stratasys, a big company in the 3D printing arena. And I co-founded the company in November 17th, together with Elad, our CTO. He knows me for 19 years. He's now also the VP R&D of the company. We're almost 20 employees after 2.5 funding rounds. Some of the investments came from Xerox and from Evonik. So I'll start now. I want to start by telling you that we have these Fortune 500 companies as paying customers of CASTOR, and we have those strategic agreements with industry leaders, mainly because those companies are afraid to be disrupted by 3D printing. It means they know that 3D printing is not about prototyping anymore. They know an end-use part can be used in an end-use environment that it was printed. The problem is that they don't have enough information and in-house expertise to use 3D printing to generate profits. This is exactly where we're entering into the picture. We're enabling manufacturers to reduce costs utilizing the benefits of industrial 3D printing, which means we first help them to decide whether to prefer 3D printing over traditional manufacturing methods when it can save them time and money. And second, we help them to gain confidence, to feel what it means to replace a part with a cheaper part in 3D printing. We do that by analyzing CAD files, CAD, computer-aided design files. And within that, we have 3 major technologies. Either we analyze thousands of parts at once, which means companies usually using CASTOR as a screening tool to upload the whole dashboard of a car or the whole inventory list of spare parts and get an answer within seconds whether there are opportunities for cost reduction within those parts using additive manufacturing. We do that based on the design as is or based on design changes, which we recommend to do. We have a patent, for example, for parts consolidation, to combine multiple parts into one, and for weight reduction, to reduce weight. We actually provide a hollow part that is empty from the inside, that is strong enough, like the fully dense part, according to a likelihood to failure analysis we do in the software based on Finite Elements Analysis. This is how it works. The algorithm analyzes a full BOM, as I've mentioned, bill of material, database of parts, distinguish between the interesting parts to the non-interesting parts, and on the interesting parts provide a report based on material properties, geometry limitations, the financial break-even point versus traditional manufacturing methods, and, as I've mentioned, a stress analysis that predicts whether the part will fail or not, or how it will behave in the real life, according to a mathematical way we've generated. Here is a small example. This is how a combined part, instead of 3 different parts, as a combined part, this assembly saved HP Cytex about $65,000 a year, about $400 per such combination of a part. We sell software, which means we do that either on a cloud-based solution that's called CASTOR Lite, analyzing the parts based on their design as is. We either sell an on-premise software That's with those design changes recommendation that I've mentioned, and we either have a white label version. This means we provide our software to large players in the additive manufacturing arena that they can give this solution to their potential customers. This is what we're doing with Evonik. This is what we're doing with Xerox. This is what we're doing with others. And we have a very good go-to-market strategy through that. We're now opening our A-round session. So if you'd like to hear more, I would love to answer questions about that or any other questions after the pitch ends. Thank you.
Great. Okay. Online, offline, first row. Let's go. Oh, and online also coming up. Please.
Thank you, Oma. Let me play devil's advocate. At the moment, I fully agree. The designs, the development of the parts are done by people who are not really familiar with 3D, with AM. But as more and more entering really and starting to design from or for AM, will then your product not become obsolete?
That's a good question. Thanks for that. So I would say that as a startup, first, we're trying to run from educating the market to think 3D printing when they start to design. It means we rather tackle the production engineers rather than the mechanical engineer who designed the part and show the cost saving to the production engineer in a way that he can convince the mechanical engineer to think 3D printing when he designs. So I agree with the first statement. We have a plan of what to do next, which means a complexity management system, what printers, what materials, what you need to do if the part was already designed for additive manufacturing. But I still think there are a lot of mileage to go until we will reach that point where engineers will be educated enough to think 3D printing when they start to design. Enough means that CASTOR as a company can grow to be a matured company, and we need few small steps to get there.
Okay, I will take the question from online here, and then we will go to the back.
Our online audience asks, what materials do you consider for your 3D printed parts, and what kinds of 3D printing methods do you consider?
Great, that's a good question. We're agnostic basically to the input, to the CAD files we get, and to the output, which means the recommendation of what we think is the best mesh solution for the parts we found as suitable for additive manufacturing. It means we do both plastics and metals. If the part was designed in plastic, probably the recommendation of the algorithm would be a plastic case, and the same for metals. We only do industrial grade additive manufacturing, which means the parts should be provided through a service bureau that have this technology in-house, and it is mature enough that it's not an R&D material, it's not an R&D printer, it's really out there in a service bureau that somebody can click on a part and get the part to his factory. About 30 different metals with 50 different printers, about 100 different printers in plastics. So the matrix of the combination between them is pretty large.
Okay, next question, please, at the back.
Yes, my question would be, where do you see, in which markets do you see the 3D printing especially interesting? Question one. And question two, are you open for all manufacturers of 3D printing machines, or are you focusing on a few?
Thanks. So who leads the market today is in additive manufacturing. Adoption is automotive, aerospace, medical devices. We're not focusing on those companies, I must say, although we have Hyundai and Maxim Wheels that you saw on the slide. We're focusing on industrial machinery manufacturers, very low volume, very high complex, high mix parts. Low volume means thousands of units being sold in a year. High mix means very high sensitivity to the price of a part. So this is the focusing we are focusing on. We are not focusing on a specific technique, but we are heading towards metals and use manufacturing. This is why we partnered with Xerox, which is leading the market in aluminum 3D printing.
Okay, and I think that's it for this round of questions. Always so fast. Thank you very much.